Hi everyone, today I'd like to share with you an experiment I've been working on for the past few days. And it's in very long exposure star trails photography taken from the ISS. This seems like a very niche thing to work on, and it's inspired from a picture that Thomas Pesquet, a French astronaut, posted to Twitter on mid-June. In Thomas's picture, we can see the stars rotating in the background and the Earth rotating underneath the station as it orbits the Earth. To work on this, I went to some Expedition 57 pictures that you can freely download from the internet. And here we can see the stars rotating in the background. We can also see the Earth rotating underneath the space station. And we can see something similar to what Thomas's picture caught, but it's not a long exposure. We can also see the solar panels of the ISS moving to track the light, and by the end of the video the sun rises and washes out everything or almost everything in picture. Now, let's see if applying some image processing we can get a result that looks similar to Thomas's picture. In the video, I will show how the images are formed, as if they were being taken by the camera or we were able to develop the film or develop the sensor as it's being taken. So, for starters, we're going to try stacking all the images using a maximum mathematical function. That means that for every pixel in all the different pictures, we're going to keep the biggest value, the maximum value that we've ever seen at that pixel. And you can see that this sort of works. We can see the stars moving in circles, the Earth in the background also rotating. And when the panels move, we see that we start to get light in our sensor at that point. It works fine, it looks similar to Thomas's picture, but it's a bit too bright. But the problem is that since everything is so bright, we're washing out and we're missing some details. So let's see the other one. When we use the sum function, what we see first and foremost is that the whole picture is better looking in general. Not just a particular thing, but it looks like a bit more natural, it looks closer to Thomas's picture. We can also see that we have a better view of the air glow. See, right at about the middle of the video, of this video representation, we can clearly see the air glow in the atmosphere that was visible in the main video, and it was completely washed out in the maximum version. Now, the only problem that we have is that the stars are very, very dim. And that comes from a result because since I worked these from JPEG files that have a maximum value of 255 for every single value, pixel value per channel, and we're dividing it by constant number to keep things in tone, to keep things visible for us, then the stars suffer a bit from this processing. I could compensate for that if I had access to the raw files from the camera where I could read much precise values for intensity, for light intensity, or perhaps with even a bit more of image processing, we could do something to just brighten up only the stars. So there's still a bit of room for improvement in this kind of pipeline. As for the final picture, I'm just showing it right now and showing details of it. I'm going to upload it to Reddit probably and link the image in the description below, so check that out if you want to see how it looks like and go into the details on your own. And that's all I have for you today. Hope you liked it.